Hello, everyone. Good morning, afternoon, evening. Am I audible? Can someone just confirm if I'm audible?
Yes. Yes,
Yes.
ma'am.
Thank you so much.
Yes, ma'am.
Thank you so much. Hello, everyone. Dear authors and invited guests, welcome to Technical Session 2C. Myself, Priyanshi Goyal, and I will be moderating this session today. On behalf of Global Knowledge Research Foundation, and GR Scholastic LLP. It is my great pleasure to welcome you to the International Conference on Machine Learning, on Machine and Computing Technologies for Sustainable Development, MCT4SD 2025, Manila, Philippines. The conference is being organized in a hybrid mode. The physical event was held yesterday in Manila, Philippines, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th of December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. Just a second. Yes. So, as I was saying, the physical event was held yesterday in Manila, Philippines, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th of December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Hemlata Vivek Gaikwad. Do we have you here with us, ma'am?
Yes, ma'am.
Welcome, ma'am. Thank you so much for joining us to chair this session. I would request you to share a few welcoming remarks for the participants before we commence the session.
Hello.
Yes, ma'am.
Uh, I think I don't know what time you have there. A very good morning to all the participants. And as Dr. Priyanshi has shared, I hope all of you will be benefiting through the shared knowledge which we are going to have this from this program. And each presenter, I think, should stick to what guidelines she has issued. Also, I think if you will focus a little bit on introduction, then your objectives, methods, findings, and maybe few recommendations which you have given. So that will help you in completing the presentation in 12 minutes. And all the best to you. And I hope you all will learn from each other's knowledge.
Thank you so much, ma'am, for your kind words. And now, without further ado, let's start with today's session. Moving forward, I would like to call the first presenter for the day, Sir Mahesh Basavarsh, for presenting his paper titled A Taxonomy of Security and Privacy Challenges in Immersive Virtual Reality. Do we have you here with us, sir? Is anyone else from the team present? Since no one is responding, I will move forward to the next presenter. I would like to request Ma'am Ursuli Adoresian I'm sorry for if I've spelled it wrong, to kindly present your paper titled Artificial Intelligence in Higher Education, Faculty Awareness, Perceptions, and Institutional Readiness Toward AI-Generated Academic Work. Ma'am, do we have you here with us?
Yes, ma'am. Good afternoon.
Good afternoon, ma'am.
Please allow me to screen share first my
Yes.
presentation.
Yes,
Thank
you
you
can
po.
share it.
Thank you. Alin? Present natin.
Full screen.
Alin ka? Ito. Wait.
Naka-off ba camera mo?
Naka-off.
Naka-off microphone mo.
Where's it? For a while po,
Hello, yes, ma'am. Are you presenting the screen? Yes, your screen is visible. However, you're on mute.
good afternoon. Am I audible, ma'am?
Yes, you're audible now and your screen is visible. You may start.
Okay, good afternoon to everyone. Distinguished fellow researchers, I am Dr. Arcelia Adoracion Ramos from Pangasinan State University, and it is my privilege to present to you the findings of my study entitled Artificial Intelligence in Higher Education, Faculty Awareness, Perceptions, and Institutional Readiness Toward AI-Generated Academic Work. This presentation examines critical trends emerging within the academic sector as generative artificial intelligence rapidly reshapes education practices. The expansion of AI-generated tools presents unprecedented opportunities for efficiency and instructional enhancement, yet simultaneously raises complex ethical, pedagogical, and institutional challenges. Allow me to begin by outlining the context that motivated this research. The global search for generative AI tools such as ChatGPT, DALL-E, and other automated writing and research assistants has transformed how academic content is produced, consumed, and evaluated. Faculty are increasingly confronted with highly sophisticated student work that may be partly or entirely generated by AI. Existing policies, however, have not kept pace with this sudden technological shift. This situation places educators at the front line of dilemmas concerning academic integrity, authorship, and assessment validity. Within the Philippine context, where technological adoption varies widely across institutions, the urgency for empirical evidence on faculty perception and readiness becomes even more pronounced. The objectives of this research is to describe faculty demographic and professional profile, to assess their awareness and experience with AI-generated academic work, to explore faculty perceptions of AI in generated work, including perceived benefits, risks, and ethical concerns, and to evaluate faculty recognitionability of AI-generated content. And last is to examine perceived institutional readiness and policy needs concerning AI use in academic settings. For the methodology, the study employed a descriptive survey design involving 30 faculty members from various departments. Respondents completed the structured questionnaire consisting of 8 major sections aligned with the research objectives. The instrument was designed to capture both the cognitive and experience dimensions of faculty interaction with AI, including their awareness, perceptions, behavior, and readiness. Weighted means and descriptive statistics were computed to analyze the response patterns. For the results and discussion on the first, on in the faculty profile, the findings indicate a young, predominantly female faculty with moderate teaching experience and substantial AI familiarity. These characteristics suggest readiness to adopt AI or artificial intelligence in academic tasks through capacity building and policy guidance remain for effective integration. With regards to faculty awareness and experience with AI-generated work, they demonstrated moderately high familiarity with AI, with 70% respondents reporting moderate to high knowledge of AIs. The majority recognize that AI is capable of generating complex academic work and acknowledge having encountered student submissions that appear to involve AI assistance. However, a critical finding emerged despite this heightened awareness. Faculty expressed only moderate confidence in detecting AI-generated text. This indicates that while educators are increasingly aware of AI's capabilities, they remain uncertain about distinguishing authentic student work from assisted AI-assisted content. Faculty demonstrate high awareness and moderate engagement with AI tools. However, uncertainty in detection underscores a gap in practical skills and institutional support, reinforcing the need for professional development and AI literacy programs. In terms of uh, perce- perceptions of AI in student work, it revealed a careful balance between perceived benefits and risks. Faculty agreed that AI can substantially improve the quality of writing, enhance clarity, and provide structured assistance to learners. They also recognize the ability to reduce faculty workload through automated feedback and instructional support. They recognize AI's pedagogical potential while remaining cautious about ethical and integrity-related challenges. Results emphasize the importance of institutional frameworks to support responsible AI use. On observed student behaviors, as observed by the faculty, a majority indicated that they had suspected instances of AI use and they had taken action when necessary. Many have already implemented changes to their assessments, such as requiring oral defenses, in-class writing, and process-oriented tasks. These adaptive strategies underscores the growing recognition that traditional assessment methods are increasingly vulnerable to exploitation through AI. The faculty are actively responding to AI integration by adopting assessment strategies and monitoring student work. Professional development in AI detection and literacy remains crucial. In the perceived benefits, faculty, this is acknowledged by faculty, AI's potential to support learning. AI was recognized as a powerful contributor to student comprehension, efficiency, and creativity. And at the same time, faculty reiterated that such benefits must be accompanied by clear ethical frameworks and institutional policies to ensure responsible use. In terms of the risks and ethical concerns, faculty expressed strong agreement that AI threatens academic honesty when used without acknowledgement. There were also concerns about algorithmic bias and data privacy, aligning with global discussions on the ethical governance of AI in educational environment. While recognizing AI benefits, faculty emphasized the importance of ethical frameworks, training, and policy development to balance innovation with academic integrity. As to the recognition of AI-generated text, faculty demonstrated moderate competency in identifying AI content, signaling the need for ongoing digital literacy training to strengthen detection skills and ensure academic authenticity. Faculty vary widely in identifying AI-generated text, indicating intuition alone is unreliable. On institutional readiness and policy perspectives, perhaps the most compelling section of findings pertains to the institutional readiness. Faculty strongly agreed that universities must urgently develop clearer policies on AI, provide faculty training, and educate students on ethical and responsible AI use. They also asserted that AI should not be banned, rather, it should be integrated into instruction within a structured, transparent, and ethical framework. This underscores the shift from AI avoidance toward adaptation and collaboration. To summarize the discussion, these findings suggest a multi-layered narrative. Faculty are not resistant to AI. Rather, they are keenly aware of its pedagogical value, but are constrained by insufficient guidance and inconsistent practices. The results illustrate a readiness to embrace AI, provided that institutions support them through policy, training, and assessment redesign. Faculty members are operating in a landscape where they are simultaneously learners, evaluators, and gatekeepers of academic integrity. Awareness is high, but skills and policy support lag behind. Assessment redesign is emerging as a practical response. In conclusion, this study highlights the urgent need for higher education institutions to transition from passive observers of AI trends to active creators of AI governance frameworks. Clear policies, targeted faculty development, student education on ethical AI use, and authentic assessment are essential for aligning innovation with academic integrity. AI holds extraordinary potential to enrich teaching and learning, but this potential can only be realized through responsible, guided, and well-regulated integration. AI offers benefits, but threatens integrity without policies and training. For the recommendations, stab- establish a clear institutional AI policies. Another is to provide faculty literacy and detection training. And we also need to educate students on ethical and responsible AI use. And we have to shift to authentic process-oriented assessment. Thank you for your attention, and I welcome any question or discussion regarding this research.
Thank you so much, ma'am, for your presentation. Do we have any questions?
Wait, I need to return to the Zoom.
You can just stop recording, just stop presenting.
Yes, but wait, I will stop sharing. Okay. Uh,
Yes. Are there any questions?
Hello.
Good afternoon, ma'am.
Good afternoon. Uh, what I wanted to ask you, your first objective was to collect the demographic profile,
Yes, ma'am.
but you have not used it anywhere in your findings. So, what have you done with that demographic profile which you have collected?
That's to determine the if, say for example, in the age bracket, if
Hmm.
those above 50 are still using AI or could still cope up with the AI generation po.
Mhm. And like if you can show the correlations or the impact, like which if faculty demography is in this age group, so how they are, like maybe those who are in higher age group are not preferring AI. So have you shown such correlations? I couldn't see.
Uh, it seems it's I was not able to place it in my slide, but it seems it's there present in the full paper po.
All right.
I
Okay.
miss it in the
Okay.
slide
Okay.
presentation.
No issues. Otherwise, a very relevant topic. And
Yes,
yes, and I think you can in the paper if it is there, your hypothesis testing and all. That's great. Yeah.
yes, ma'am.
Yes.
Noted po.
Yeah. Thank you. I think that's all. That is the only thing which I could see. Thank you so
Thank
much.
you.
Yeah.
Thank you, ma'am.
Thank you so much, ma'am. Moving forward, I would like to request Sir Raymond Bryan to kindly present his paper titled Development of Pangasinan State University Instructional Materials Management System, PSU IMMS, a technology process integration. Do we have you here with us, sir?
Yes, hello, ma'am. Good afternoon.
Good afternoon, sir.
Am I audible, ma'am?
Yes, you're audible. You can share your screen now.
For a while.
Yes, your screen is visible. You may start.
You can now see my screen, ma'am. And am I audible, ma'am?
Yes, you're audible and your screen is visible. You may start.
Yes, thank you. To our scholarly committee members, to our chair, Dr. Himlata Gikwad, to our moderator, Miss Priyanshi Gayal, and to my fellow researchers, a pleasant afternoon. Um, I, Engineer Raymond Brian M. Smenda, together with Dr. Clark Kim C. Castro and Mr. Leo Gabriel V. Villanueva, is honored to present to you our study entitled Development of Pangasinan State University Instructional Materials Management System, or the PSU-IMMS, a technology process integration. This research focuses on integrating technology into academic processes to improve efficiency, transparency, and workflow optimization. Higher education institutions today face increasing administrative complexities. Traditional manual processes, particularly in managing instructional materials, often cause delays, inconsistencies, and heavy administrative workload for faculty. Recognizing these challenges, our team set out to design a system that not only automates processes but also improves overall institutional management practices. PSU IMMS, or the Pangasinan State University Instructional Materials Management System, was developed as a targeted and evidence-based solution. In our institution, faculty frequently reported inconsistencies in instructional materials management. These concerns include long processing times, unclear workflows, and a lack of transparency in evaluation procedures. However, despite these reports, there was no empirical measurement of how serious these problems were or how strongly they were linked to current management practices. This gap became the driving force behind our investigation. Before developing the system, our study established both a general objective and a set of specific objectives. Our general objective is to design, develop, and validate an instructional materials management system for Pangasinan State University. To support this, the study pursued the following specific objectives: to quantify the current state of academic management practices and the perceived seriousness of operational problems encountered by faculty, to determine whether there is a statistically significant relationship between the level of management practices and the seriousness of the problems, and to develop and validate the PSU IMMS in terms of its functional utility, user acceptability, and technical performance. These objectives ensured that the system was grounded in empirical findings and aligned with the operational needs of the institution. Our system is guided by technology acceptance model, where user acceptance depends on perceived ease of use and usefulness. The development approach also followed information systems principles, specifically functionality, efficiency, and reliability, ensuring that the system is both technically sound and user-centered. To achieve our objectives, we applied a mixed method approach, a descriptive correlational survey involving 315 faculty members, and a developmental method using the iterative systems development life cycle. The survey used Likert scale measures, analyzed through weighted mean and spear rank correlation. System validation was conducted through user acceptance testing and a technical audit using Jetty metrics. From the survey, we found that the current management practices were well implemented with an overall mean of 3.21. However, faculty still experience several operational challenges, reflected in a seriousness rating of 2.33. The most notable issues were technological difficulties, limited interactivity of materials, and limited feedback mechanisms. These results showed that even if system exists, there is significant room for improvement. One of the most important findings of this study was a statistically significant negative correlation between management practices and seriousness of problems. With a Spearman's rho of negative 0.178, the data shows that as management practices improve, the severity of problems decreases. Although the correlation is weak, it is meaningful and statistically valid across large sample. This finding became our empirical justification for building Pangasinan State University's Instructional Materials Management System. Based on our diagnostic results, we proceeded to develop PSU IMMS using the Iterative Systems Development Life Cycle. The system supports multiple user roles: the faculty, evaluators, CFL staff, or the Center for Foreign Language staff, the Curriculum and Instruction Office, and the Vice President for Academics and Student Services. It automates the entire evaluation and approval workflow, integrates plagiarism checking, and provides tracking, feedback, and record-keeping features. The goal was to standardize the entire process, reduce workload, and enhance accountability. So the diagram illustrates the full workflow from faculty registration and validation to faculty uploading their instruction, plagiarism. Afterward, they move through campus level and university level evaluation to CI, or the Curriculum for Instruction evaluation, and finally to the Vice President for Academics and Student Services for approval. So once approved, the materials are officially published and certificates of ownership can be generated. This structured process ensures consistency and transparency. So this is a sample of a screenshot showing the interface of PSU IMMS. We designed the system to be intuitive and easy to navigate, ensuring that even non-technical users can efficiently carry out their tasks. Under the user acceptance testing, it has yielded an overall acceptability score of 3.83, which is then interpreted as highly acceptable. Particularly, faculty appreciated effective management, easy access, seamless integration, and effective tracking and recording features. This validates that the system meets the expectations of the intended users. We also conducted a technical audit using JETI metrics. The system earned a grade B with a performance score of 75% and a structure score of 94%. For the functional evaluation in terms of functionality, efficiency, and reliability, it is also highly acceptable. These results demonstrate strong optimization, efficient coding structure, and readiness for institutional deployment. In summary, PSU indeed faces operational issues rooted in inconsistent manual processes. A negative correlation exists between poor practices and problem severity. The Pangasinan State University Instructional Materials Management System effectively addresses the identified gaps, improving workflow efficiency, transparency, and administrative productivity. In conclusion, the dual phase approach of this study proved successful. We were able to diagnose institutional issues, design a suitable technological intervention, and validate its effectiveness both subjectively and technically. PSU IMMS stands as a scalable, evidence-based, and institution-ready solution for instructional materials management. We recommend that the phased rollout of PSU IMMS across all campuses, along with training sessions for faculty and administrators. The continuous system enhancements is also encouraged, aiming for even higher performance grades. We also recommend conducting a follow-up study 12 to 24 months after implementation to measure long-term impact. And lastly, benchmarking with the systems from other universities. And that will be all. Thank you for listening. Maraming salamat po.
Thank you so much, sir, for your wonderful presentation. Do we have any questions?
Hello.
Hello?
Hello, ma'am.
Hello.
Ma'am, your voice is breaking.
Uh, Hello. Am I audible now?
Yes. Yes, ma'am.
Yeah. I think a very good presentation, and 315 is a good sample size. And what I wanted to know is when your this ratings came around, I think 3.85. And so for remaining, did you identify any issues for why your ratings were 3.85? I think out of 5 you have rated.
Yes, ma'am. We encountered issues related to role-based access complexity workflow, access complexity, workflow alignment across different evaluator levels, and ensuring smooth integration with existing institutional policies. So these were resolved through the iterative refinement and continuous user consultations.
Okay. And one more thing I wanted to know, like these 315 faculties which you took, were they a part of assessing this system, or you have taken inputs from them while developing this system?
They are part of the when they are accessing the system, they are part of the assessing the system, ma'am. Those
Okay.
315 faculty members, Pangasinan State University.
And for developing, from where did you take inputs?
Pardon, ma'am. Sorry.
For developing this system, from where did you take the inputs?
Coming from the we got the inputs coming from the what do you call this one? The traditional or the problem of the administration and also the faculty members.
Okay, okay. Because my suggestion is for inputs also, if you will, like, or maybe you can take feedback from the faculties from which you have taken, like,
Yes, ma'am.
what are the lacunas, and if you can work on that, that will, I think, make you, otherwise, a very good system you have developed. That is a problem with many of the universities.
Yes, ma'am. They are part of the feedback mechanisms of the system, ma'am. So that is why we have chosen the iterative method to be able to improve the system from time to time.
Yes, 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 yes. Congratulations, sir. Very good paper. Thank
Yes,
you.
ma'am. Thank you very much, ma'am.
Thank you very much, sir. Thank you, ma'am. Moving forward, I would like to request Ma'am Arceli Adoracion Ramos to kindly present her paper titled Exploring Students' Perceptions, Ethical Beliefs, and Practices on the Use of Artificial Intelligence in Education. Did we do it earlier? No, that was different. Sorry. Ma'am, are you here? Ma'am Ramos, do we have you here with us? I think you are mute because I can see you in the meeting. Since no one is responding, I'll move forward. I would like to request Sir Saurav K to kindly present his paper titled Obfuscation in Malware, Trends, Challenges, and Defensive Innovations. Sir, do we have you here with us?
Hello, can you hear me?
Yes, sir, I can hear you. Let me
Yeah.
just. Yes.
Let me proceed.
Yes, please share your screen.
Is it visible?
It's visible, but there is like blocks visible on the side. But I think you can take it forward. It's okay. Yes, it's visible and we can hear you. You may
Okay.
start.
Good morning, all. I'm Saurav from Department of Computer Science and Engineering, National Institute of Technology, Calicut. Today, I will present you our survey on the topic obfuscation in malware, trends, challenges, and defensive innovations. Let's begin. So, first of all, obfuscation is the process of intentionally making the code difficult to understand, ensuring it remains fully functional in the computer. Obfuscation has become a central technique used by modern malware to evade detection. Originally developed to protect legitimate software, these techniques now make reverse engineering difficult and defeat signature-based approaches. Because obfuscation continues to evolve rapidly, there is a growing gap between the attacker capabilities and current defensive mechanisms. So, the goal of this survey is to provide a structured and updated understanding of the malware obfuscation techniques and the corresponding defensive strategies. Our contributions are threefold. Firstly, we present a comprehensive taxonomy covering encryption, polymorphism, metamorphism, code transformation, and virtualization. Second, we evaluate static, dynamic, and hybrid detection method that is currently in use. Uh, Third, we highlight the increasing importance of memory forensic as a critical detection layer that many surveys outlook, which is the main focus of this survey. So coming to the taxonomy, obfuscation can be categorized based on how the code is transformed. Common classes include encrypted and polymorphic malware, metamorphic malware, local code transformation, and virtualization based. These techniques target different aspects of the program structure, such as opcode patterns, control flow, data flow, and execution environment. The key idea is that the underlying behavior remains the same, while the observable structure become extremely difficult to analyze manually. So going in detail, encrypted or packed malware stores its payload in encrypted form and decrypts only at runtime. Static tools cannot inspect this encrypted content, making the early detection very difficult. And polymorphic malware takes this further by mutating the decryptor on every infection. That is, the code changes on every infection automatically. Although the payload stays the same, each instance appears unique, breaking traditional signature method. Uh, and both techniques significantly reduce the effectiveness of static analysis. Coming metamorphic malwares, it rewrites its own code with each generation. It may change instruction sequences, reorder blocks, insert junk code, or substitute equivalent instructions. This eliminates any stable uh, opcode patterns, forcing defenders to rely on semantic or behavior-based analysis. And local code transformation shows while although it's smaller in scale, it follows the same principle. Countermeasures include opcode statistics, control for graph analysis, and symbolic execution. all of which focus on semantics rather than syntax. And finally, virtualization-based obfuscation malware uh, translate its original machine code to a custom bytecode and execute it inside an embedded virtual machine because the native logic is hidden inside this virtual layer. Reverse engineering becomes significantly more difficult. Attackers can stack multiple virtual machines to increase complexity also. Defensive techniques such as devirtualization, taint tracking, or symbolic execution are helpful, but computationally very expensive. Coming to the current detection scenario, static analysis inspect binaries without execution. That is uh, in the executable format without execution in the disk itself. It is fast and scalable, but it struggles with encrypted, packed, or heavily obfuscated code. And whereas dynamic analysis observes the uh, behavior during the execution and can reveal unpacked payload, but it is vulnerable to anti-virtual machine or anti-sandboxing mechanism used by malware, and it is currently done manually. Um, Comparing this to, we have a hybrid analysis attempting to extract more reliable features while mitigating individual weaknesses. Hybrid system integrates static features like opcodes, dynamic behavior such as system call traces. These uh, approaches is useful for detecting multi-stage malware that decrypts itself incrementally in memory. And also there is machine learning and deep learning techniques which use features such as graph or code sequence, memory artifacts, and API traces. Although this model perform well on benchmark data sets, they often fail to generalize to zero-day malware and vulnerable to adversarial manipulation. This highlights the need for more robust and representative data set uh, based detection. Many malware families decrypt or uh, reconstruct their actual code in the RAM, making memory forensic an essential detection layer. Through memory analysis, investigators can recover unpacked payloads, injected modules, hidden processes, and suspicious memory regions such as read-write execute pages. The workflow includes memory acquisition, preservation of integrity, and analysis using tools like volatility or recall. Our survey emphasizes that memory forensics is an often overlooked in existing literature, but is crucial for detecting modern obfuscation malware. This slide summarizes how obfuscation techniques map to different analysis layers and the corresponding countermeasures. At the code level, techniques like metamorphism, target disassembly, and structural analysis. At the runtime level, dynamic behavior can reveal hidden logic that static techniques miss. But at the memory level, decrypts artifacts and reconstructed components become visible. By fusing evidence across all three layers, detection system becomes significantly more simple and robust. Moreover, it can be automated. This figure simply visualizes the relationship between obfuscation techniques, the analysis layers they target, and the defensive strategies currently associated with each layer. The purpose of this mapping is to provide a clear understanding of where existing defenses fall short and where new opportunities for detection arise. Now, so comparative insights, static analysis often fails when structural obfuscation or packing is applied. Dynamic analysis is more powerful, but can be evaded and is expensive to scale using heavy computational resources. Hybrid approaches offer improvements, but still inherit the weakness from both sides. Also, there is machine learning models face generalization problems, particularly against new malware families. Memory-based approaches reveal crucial artifacts, but are still largely manual and require intervention. Due to the challenges currently faced, key challenges include automating memory-centric workflows, detecting kernel-level and distributed malware, and building machine learning system resilient to adversarial attacks. Future directions involve developing memory-aware detection frameworks, which is fully automated, uh, looking into a live memory behavior, and enhancing automated deobfuscation, devirtualization, extracting richer features from the volatile memory, and focusing on operational robustness rather than only offline accuracy metrics. So key takeaways are first question is fundamental to modern malware, and traditional static signature are no longer sufficient. Effective defense requires multi-layered analysis that integrates code-level, runtime, and memory-based insight. Hybrid and machine learning-based detection can help, but must be strengthened with a deeper semantic and memory-aware approaches. Our survey calls for building a more automated and resilient detection ecosystem that fully incorporates memory forensics. Thank you for your attention.
Thank you so much, sir. Are there any questions?
Any questions from the participants? Okay. Saurabh, can you just one thing I wanted to know, how does your obfuscation method is affecting time and space complexity?
Obfuscation method means it is a method used by malware authors to create malwares.
Hmm.
In current days, it can be hidden from normal operation. That is, a normal user can't observe it. It is functioning behind the scenes. It may be infecting our system as a simple executable file. It may seem as a benign application. So our task is to classify it on time before infection, because once it started executing, it can be it is possible it can take very long period of time to slowly start infecting. That is basically I meant by long-term infection, which can be basically it incrementally decrypts on memory and started infecting the computer. So it is hard to detect by a normal user.
I think there's a power cut on ma'am's end. Thank you so much, sir, for your presentation. We will take it forward to the next presenter while ma'am is rejoining. Thank you so much. Next up, I would like to request ma'am Sangeeta Rajole to kindly present her paper titled Optimized Resource and Task Allocation in Edge Computing, a Comprehensive Study. Do we have you here with us, ma'am?
Yes, ma'am.
All right. Yes. You can share your screen. Yes, it's visible. You may
Yes,
start.
ma'am. Okay, ma'am. Good morning, good afternoon to everyone. My title is Optimized Resource and Task Allocation in Edge Computing, a comprehensive study by myself, Sangeeta Rajuli, and with me, Dr. Menika Ghelawat. I'm from Lok Jagrati Kendra University, Ahmedabad, Gujarat, India. Usually, the topic is extremely important because modern IoT systems generate a huge amount of data, And to manage this data efficiently requires smart computing strategies. So because of that one, there is an introduction to the cloud computing. Cloud computing is what storing and accessing of a data over a computing services over a internet. So here, whatever the data which were coming from the IoT devices or sensors, cameras, or anything else, that is going to be safe where there is a cloud computing. We are going to save the data on a cloud computing. But traditionally, the cloud computing is one of the important thing. Nowadays, what is happening due to the latency increase and due to the IoT devices increase, what we want some mediators to handle this particular storage or to handle this particular services. So because of that one, the concept which was arise, that is edge computing. So usually edge computing, the one which I have shown here, that is uh, that is edge computing usually is what that is shifting the processing closer to the data storage. Usually, if at all will store a data on a cloud, that time there is a lot of queue is going to be generated. Because of that one, the data is not timely given to the users. To avoid this one, there is a edge computing where they have given here, I have shown here, three-layer architectures where the first bottommost layer, that is IoT devices like sensors, vehicles, and camera. Now, these devices will send the message to the edge computing gate through intranet. Here, the real-time data processing is done, and the data storage will be fired to the cloud-based data. Means big data is going to be stored there, and the data which is going to be sent from the edge to the sensors is done with the help of edge servers. Means storage is done and the message is going to be passed to the IoT sensors or receive the messages from the IoT sensors, that is with the help of edge computings only. Only the storage is going to be given to the cloud. So this is a three-layer architecture which is given. Now on the edge, whatever the virtual machines are available, how it will allocate the task. So here, whenever the VM is going to be selected, okay, first the system checks the user locations. Okay, then use the utilization of physical machines and then it decides whether the placement is going to be done or it will be migrated. Once the VM is allocated, next step is what? That is how we can um, decide which task should be offload and whether they should be executed or not. So for this one, what we are going to do, we are going to give a task offloading. So task offloading means what? Sending heavy computation tasks from IT devices to the edge servers or sometimes to the cloud servers. The purpose of edge computing is task offloading is what? To reduce the latency, to save the energy, and to reduce the workloads and improve the system performance. Because every resource every resource will have different configurations and different capabilities. Because of that one, every task is not given to the particular edge nodes. So there are the challenges are available that are multi-objective optimization problem, which that means balancing delay, energy security, dynamic network environments, limited storage on the computing power of the edge, mobility of devices, heterogeneous devices with different capabilities. There is a limit to the latency deadlines to the task and network availability. Okay, for these challenges, some of the papers I found, that is, they have given the mathematical operation research models, which is used to maximize the total task completion time, which includes transmission and processing of a data, which will minimize the task completion time. Means in a minimum task, in a minimum transmission and processing, what we have to do, we have to complete that particular task. Now the constraints which I have taken here, that is what each task should be assigned to only one node unless and until the node is going to complete that particular task. And the second one is what each node can access only one task. Okay, beyond that one, the capacity of that particular node is not available. So that is that constraint you have to check. And the latency means each task must meet its latency deadline requirements. And so some of the papers, they have only done the mathematical operation research model to allocate the tasks to the particular nodes. And some of the papers I have seen that they have given task offloading methods, because in every methods is having their own importance. So based upon that one, I have given the edge based architecture here. So the task offloading methods is based upon resource aware task allocation, quality aware task allocations, distributed task allocations, collaborative task allocations, energy efficient task allocations, machine learning based task allocations, and context aware task allocations. So some of the tasks which is run using the operation research model, and some of the tasks I have seen that they have used machine learning predictive models such as goal-based predictive tasks and reinforcement learning task allocations. So here I have given some the one which is used by many papers, and here I have elaborated that in each and every task allocation, what is the main allocation is done, whether it is a storage allocation is done, yeah, whether it is a computing resource allocation is done, and whether it's a communication resource allocation is done. So what approach they have used, whether there is a greedy approach is there, yeah, top down approach is there, and whether they have used static resources or dynamic resources, hybrid resources. Like this I have given the task offloading methods, which is based upon task allocation methods. And the secondly, there is a resource allocation methods, because task and resource both are independent but interdependent activity whenever you want to give whenever you want to store the data to the edge computing. So here the resource allocation types which I have given here, that are dynamic, or it is centralized resource allocations, or it is decentralized resource allocations, whether it is a dynamic mode, or it is a task statics mode, or some of the papers they have given the hybrid resource allocation methods also. And
This is a gentle 10
So,
minutes reminder.
yeah. Now the conclusion is what that is. So no one device or no one resource or task allocation is important here. So here I have given the survey presentation for the comprehensive task offloading and resource allocation approach with the edge computing architectures based upon task and resource allocations. In this one, uh, the conclusion is what that is no one system, no one resource or no one task is important. It's totally depend upon the task offloading by the resource allocation or task allocation methods. And in the future I think that there are many AI based task allocations are used, which gives stronger security and privacy aware offloading methods, which will optimize multiple objective optimization models. That is, first of all, we'll give the operation research model to optimize the model, and then we will give on the same data, we will have deep learning techniques, that is Markov change or reinforcement learning techniques to optimize that particular model to balance the latency, energy, and reliability of a data. So this is the collaborative architecture and standardized test beds to evaluate the system in a realistic environment. Thank you, ma'am. Any questions?
Thank you so much,
Hello.
ma'am.
Hello.
Hi, yes, ma'am.
Sandeeta, you have done a good study. There are few concerns which I have. Since you have seen those, you said that previous researchers have done task allocation using different approaches.
Yeah.
So you have not highlighted. I think if you put up a table where from lit review, like what method you used, from where did you get this data? Because if
So,
somebody wants to replicate your research or want to check,
uh,
so that has to be there.
actually, ma'am, I have given the same thing, the research same thing in my tables here.
Hmm.
Um, For the task allocation, I have given here what are the tasks and what are the technique they have used and what is the
Hmm.
outcome they have given for this particular task. For each
Okay.
and every task, I have written here.
Hmm.
So whether they have used dynamic or all these things,
Hmm.
and each and every table classifies task and resource allocation and how the task is connected with the resource. So
Okay.
this is a general survey I have done that
Hmm.
whether the task is important or resource is important, depending
Hmm.
upon the task and resources, how we can optimize, how we can develop the optimization model for connecting the task with the resources by using operation research model as well as using machine learning. Means I am going to combine these two optimization techniques, machine learning with optimization model to develop one optimal balanced model with the hybrid constraints.
नहीं 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 झालं व्यवस्थित थोड़ा सा स्टुडंट्स
Thank you, ma'am. Thank you, ma'am, for your presentation. Can you stop sharing?
Thank you, ma'am.
Yes. Moving forward, I would like to
Okay.
request. Yes. Moving forward, I would like to request Ma'am Ananti Mule to kindly present a paper titled Per Pixel Adversarial Perturbations for Proactive Deepfake Defense. Do we have you here with us, ma'am? Is anyone from the team present?
Good afternoon, ma'am. Maybe I can now share my second presentation.
Ma'am Ramos, we will take that presentation in the end.
Okay po.
Yeah.
Noted, ma'am.
All right. Since no one is responding, we will be moving forward with the next presenter. I would like to request Sir Mohammad Rahman to kindly present his paper titled Trust in AI as a Mediator in the Future Adoption of AI-Powered Financial Consultancy Services. Do we have you here with us, sir?
Assalamualaikum. Am I audible?
Yes, ma'am, you're audible. Will you be
Ma'am, my name is
presenting?
Sairaslam Shaki. Yes, my name is Sairaslam Shaki. I'm the second co-author of this paper.
All right, ma'am. You can share your screen. Ma'am Sangeeta Rajoli, I request you to kindly mute. Thank you so much. Yes, your screen is visible. You may start.
Thank you. Thank you for giving me the opportunity. Hello to the conference chairs, fellow presenters, and delegates joining from across the globe. It's a privilege to be presenting my work at MCT4SD 2025. My thanks to the organizations in the Philippines for facilitating this valuable virtual space. Here are the fellow co-authors of my paper. My paper title is Trust in AI as a Mediator in the Future Adoption of AI-Powered Financial Consultancy Services, and I am presenting on behalf of my co-authors. Next slide. Here is the context of our study. First one is, with the rise of artificial intelligence worldwide, AI-powered financial consultancy has become a new path for data-driven financial decision-making. As financial institutions seek personalized yet scalable services, technologies like robo-advisors and voice bots are increasingly performing advisory roles once handled by humans. Besides, AI enables 24 by 7 assistance with accuracy and consistency, making it essential in a data-intensive sectors. Next. And now, why this matters? In Bangladesh, adoption of AI-based consultancy remains limited despite the growing use of e-wallets, ATMs, POS, and other digital banking tools. AI offers time efficiency, cost reduction, and faster assistance, but concerns persist about job displacement. Financial consultancy in Bangladesh largely depends on slow, costly, and inaccessible human processes, often constrained by limited financial literacy. Then AI-powered advisory systems could improve decision making and accessibility while lowering costs, although AI applications in payments and asset management are expanding. And previous studies rarely explored the combined influence of voice bots, cost savings, personal innovativeness, convenience of use, and perceived data privacy on the intention to use AI-powered financial consultancy services. In our study, we filled the gap in how trust in AI enhances intention to use AI-powered financial consultancy services. Next. Now we discuss about the problem statement of our study. Financial consultancy in Bangladesh depends on conventional processes which are costly and slow in decision making. Though AI offers time efficiency and faster assistance, concerns regarding job displacement persist. Financial consultancy is constrained in Bangladesh due to limited financial literacy. Next. And here is the proposed solution of our study. We have identified the factors: voice bot, cost saving, personal innovativeness, convenience of use, perceived data privacy, which influence consumers' users' intention of AI-powered financial consultancy services. Then we have explored the mediating role of trust in AI in the financial sector. Then we have built a framework to enhance consumer trust in AI. Next. And here is the conceptual framework of our study. Here we can see at the left side, we have the independent variables of our study. Then Trust in AI is the mediator of our study, and intention to use AI powered financial consultancy is the dependent variable of our study. Next. Here we will discuss about the three theoretical frameworks we have used in our study. First one is technology acceptance model, which is in short we can call TAM. This shows the perceived ease of use and usefulness are direct determinants of behavioral intention to use a system, thus influencing technology acceptance. Then diffusion innovation theory describes different levels of innovativeness and how they contribute to elaborating the adoption and uses of new technologies. Then our last theory is UTAUT2. Here, AI voice bots strongly rely on anthropomorphic exchange to create a sense of trust and engagement, improving ease of use, and by adding voice quality into UTAUT2, as this model delivers a broad understanding of acceptance of AI. Next. Now we'll discuss about the literature review of our study. We will explain the variables of our study here. First independent variable is voice bot. Voice bot is an intelligent bot that will help users to interact in natural and engaging way. A higher level of playfulness in voice bots leads users to perceive a higher level of humanness and they are more inclined to use their service. Then the second one is cost saving. Here, cost saving is the amount of expenses of the user that the system reduces. Innovative technologies can reduce various costs, which fortifies the impact of cost saving on the likelihood of adoption and user's intention. The third one is personal innovativeness. PI can be defined as individual readiness to explore emerging technologies. People with high innovativeness try to absorb new information, perceive less risk, and want to try new things. The fourth one is convenience of use. Convenience of use refers to the design of the system and how easy it is for consumers to interact with it. When users find fintech services easy to use, it has no negative impact on their intention to adopt these services. Next. Our last independent variable is perceived data privacy. It handles user activities online, which include collecting information, sharing, using, reusing, and storage of data. It influences users' perception of the credibility of the system or service, boosting confidence and assuring protection of the shared data. Now we'll discuss about the mediator variable of our study, trust in AI. This refers to the fact that the consumers of this system have confidence in the outcome. Trust in these technologies acts as a direct determinant for the intention to use AI-powered technologies and actually using them. And our dependent variable, intention to use AI-powered financial consultancy services, drastically rebuilt concurrent data-driven decision-making in financial management with improved precision and automation. In today's world, AI usage in financial institutions is not optional, rather it's considered essential to meet consumers' expectations. Next. And here is the hypothesis of our study. We have shown 11 hypotheses in our study. Next. Now we'll discuss about the important part of our study, which is the methodology of our study. We have collected data from the primary data used to study factors influencing intention to use AI-powered financial consultancy services in Bangladesh, trust in AI, and IU in the financial sector of Bangladesh. Quantitative explanatory design to test hypotheses and cause and effect relationships. We have collected data from the financial service users of Bangladesh. We have used non-probability purposive sampling technique here, who have the most relevant knowledge regarding this. Then we have our survey instrument was 5-point Likert scale. We have used 5 to 6 items per construct. Our structured questionnaire has 7 constructs. Next. We have distributed our survey. We have conducted our survey via online and offline. We have via online. We have collected through the Google Forms, email, then social media like LinkedIn, email, Facebook, WhatsApp, etc. Respondents gave informed consent regarding data collection. Then purposive sampling targeting experienced financial service users, which we have described before. Then we have collected 356 valid responses. According to Klein, 2015, the minimum required sample size to conduct smart PLS is 300, but we have collected 356 valid responses, which shows that this sample size is sufficient enough to conduct this analysis. And for analysis, we have used two analytical tools. First one is SPSS. We have used SPSS for descriptive statistics and Smart PLS, PLS SEM for measurement and structural model testing. Next. And here is the result of our data analysis. Here, result of convergent validity and reliability. Here, it is shown that how well the items of this study is well enough to describe the variables. Here the Cronbach alpha values are above 0.7 and composite reliability threshold is 0.7. All the values here are above 0.7 and average variance extracted value threshold value is 0.5 and all the variables here has AVE more than 0.5. Next. And the result of discriminant validity. This discriminant validity shows how much distinct the variables of our study are from each other. Here the discriminant validity threshold is 0.85 and all the variables of our study is below this threshold 0.85. Next. And this is the result of path analysis, direct path analysis. Here we can share in the direct path analysis, hypothesis 1, 2 and 5 are rejected. Hypothesis 3, 4 and 6 are accepted. And in the indirect path analysis, hypothesis 7 and 8 are rejected and hypothesis 9, 10 and 11 are accepted. Next. Now we'll discuss about the findings of our study, what we have shown in our indirect and direct path analysis. At first, voice board. Here, voice board has not significant impact on dependent variable because most people don't want to share their financial information with voice boards. Then when the voice board variable is mediated via the trust in AI, it also shows not significant impact on the dependent variable because people don't have trust on unknown voice boards in Bangladesh. Then cost saving also don't have any direct effect on independent variable because people get negatively influenced by things if the costs are high. Then cost saving variable when mediated by trust in AI also have not significant impact because lack of awareness sway the trust of people. And here we can say that personal innovativeness has direct positive impact on significant
This is a
impact on the
gentle 10
independent.
minutes reminder.
Okay. Dependent variable. Innovative individuals are more open to accept the AI-based services, and personal innovativeness shows a positive impact by explaining that innovative users trust AI-based services more. Next. Here, convenience of users has both direct and indirect impact on a dependent variable because when consumers get introduced to a new technology, they focus on its ease of use. And perceived data privacy don't have direct impact on IUU but have positive impact on through the mediation of trust in AI because if awareness of the service can be raised by generating trust among users, it can motivate users to adopt it. And trust in AI has direct positive impact on IU because if AI-based services meet transparency standards and guidelines, consumer trust grows, which enhances their intention to give. Next. Here are the implications and conclusion of our study. In practical implications, we see that to ensure user self-assurance, companies must defend data through encoding, user control, and clear privacy applications. In policy implications, we can see that regulators will need to introduce dynamic AI-specific guidelines addressing transparency, accountability, and ethical use in financial services to stand in long-term public trust. Next slide. And here is the last slide of our presentation. We can see the limitations and future research directions of our study. This study is based on the perceptions of respondents in the current cross-sectional study, which could be distinct in longitudinal study. This study focuses on selected factors, but many other factors could impact people's intention to use AI preferential services. Future studies can collect responses from other cities to get a more comprehensive review. Adding both qualitative and quantitative element will get a nuanced result, and future researchers can also increase the sample size to get better results. Next. That's all from my part. Thank you for your attention. If you have any questions, you may ask.
Hello.
Hello, ma'am.
Saira, a very good study.
Thank
I
you.
just wanted to know how did you decide your sample size for this?
Ma'am, we have decided based on the previous literature review. We have already explained it in our presentation that we have seen in a previous literature review, which is Client 2015. From his paper, we have seen that the sample size should be 300 for conducting smart PLS. We
Okay.
have collected 356 responses.
Oh, and how did you approach the participants?
From our personal link and from we have collected data from financial users who have expertise or knowledge regarding these sectors.
That is what, because if you needed a particular type of user, isn't it?
Yeah.
Those who had this awareness. So how did you identify them? Like these are the people whom we have to select. So like that means you have used purposive sampling. So what was your
Yes, ma'am.
criteria and how did you approach those people?
Those.
Question is still to clarify the answer, please.
Thank you.
Okay, so as our student mentioned, we did purposive sampling because the goal was to find someone who already know how to use these tools, and then we wanted to understand if this is working for them or not. So we started with a pilot. We started with 20%. Then we saw like what are the basic criteria that we have to understand. The first thing we had to understand if they really have used AI-based consultancy service before. Then we try to understand like what are the understandable criteria there can be, such as like their their mode of use, their frequency of use. For example, at least 3 or 4 times they have to use that service. However, that service, the this consultancy service, is not really that popular in Bangladesh yet. So it was not possible for us to go for a high threshold. However, we actually asked them beforehand, have you used it before? We had to take their word for it, and that was how we approached them for the survey. If they said that, yeah, we are familiar with the service, we have used it, then we provided the survey. If they said we have not, then we did not.
All right. Oh, great. And I hope like you will pursue this like you have suggested longitudinal. I think that will, if you people can do longitudinal study, that will give you more valid results. And
Yeah, and that is actually required because we are just starting in Bangladesh. These services are just starting, and we have to see what happens in the future.
yes, great.
Thank you.
Thank you. Thank you. I
Thank you
think
so
I'm
much,
done.
ma'am.
I'm done. Yeah.
Yeah, thank you, ma'am. Thank you, sir. Moving forward, I would like to call again Sir Mahesh Basavaraj, if you are present, to present your paper titled A Taxonomy of Security and Privacy Challenges in Immersive Virtual Reality. Sir, do we have you with us? Are any of the team members present?
Good
All right,
after
since yes.
Good afternoon, ma'am. Can I now present my second study if the time
Yes,
is
yes,
not?
ma'am. I'll just introduce the paper title again. You can present your paper titled Exploring Students' Perceptions, Ethical Beliefs, and Practices on the Use of Artificial Intelligence in Education. I'll just stop sharing the screen. Yes, please share your screen.
For a while, ma'am. Thank you.
No worries.
Okay.
Yes, ma'am, your screen is visible. You may start.
Yes, ma'am. Yung kan belum. for a while, ma'am. Only, please bear with me. Okay. So, am I audible and my screen is visible, ma'am?
Yes, 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 ma'am.
Okay. Thank you. And once again, good afternoon. Allow me to present my second study, which is also on AI, entitled Exploring Students' Perceptions, Ethical Beliefs, and Practices in the Use of Artificial Intelligence in Education. So, as generative AI becomes increasingly embedded in academic routines, understanding how students perceive and utilize this tool is essential for shaping effective and ethical educational policies. The rapid emergence of AI tools such as ChatGPT, Grammarly, and Copilot has fundamentally altered how students approach learning, writing, and research. These technologies allow students to access instant explanations, generate ideas, and receive automated feedback. At the same time, they present new challenges involving authorship, plagiarism, and factual accuracy and algorithmic bias. While global institutions such as UNESCO and OECD have developed guidelines for responsible AI use, little empirical research has examined how Philippine students navigate these emerging technologies. This study addressed this gap by examining students' beliefs about AI's implication. What are students' ethical beliefs regarding AI use? How useful do they perceive AI for learning? How do they view artificial intelligence impact on future career? And what risks and ethical concerns do they recognize on AI use? And the last, uh, number five, what institutional policies and training do they need? And finally, how do they humanize or personalize AI generated output? The methodology of this study, this utilized a comprehensive survey instrument administered to 417 students. This employed a descriptive quantitative design using a validated instrument consisting of 6 subscales. Respondents represented diverse academic programs including education, business, information technology, and social sciences. Descriptive statistics were used to analyze patterns in beliefs, perceptions, risks, and behaviors. For the results of the study, the findings revealed that students demonstrated high ethical awareness related to AI use. They strongly agree that AI assisted work should be properly acknowledged and cited, and they express concern about data privacy and algorithmic fairness. This awareness signals that students are developing a sophisticated ethical lens through which they interpret AI generated content. However, despite this awareness, some uncertainty persists regarding proper citation procedures, highlighting the need for explicit instruction on AI referencing and academic honesty policies. They show high ethical awareness but need explicit instruction on AI citation and academic honesty. On perceived usefulness of AI, they generally perceive AI as a valuable academic aid. They report that AI helps them understand difficult concepts, saves them significant time, and enhances engagement. Nevertheless, they express moderate agreement that AI improves their grades or should be integrated into more courses. This measured response reflects a cautious balance between recognizing AI's benefit and acknowledging the importance of genuine, effortful learning. They value AI for understanding difficult lessons and saving time, but remain cautious about over reliance. In examining perceived career impact, students agree that AI literacy will be essential in their future professions. They recognize AI's potential to create new job opportunities, but also express concern about job displacement. This ambivalence mirrors global discourse on AI and underscores the need for higher education institutions to prepare students for an AI-driven workforce. Through a through cross-disciplinary AI literacy program. They believe that AI skills are essential for future careers, but fear possible job displacement. On risks and ethics, students express clear concern about plagiarism and academic dishonesty when using AI. They also report reasonable familiarity with institutional AI policies and acknowledge the importance of verifying AI generated information. Students understand that reliance on AI requires heightened scrutiny, particularly given the possibility of hallucinated or fabricated outputs. They are aware of plagiarism risks, privacy issues, and ethical considerations, but need stronger critical evaluation skills. In terms of policy and training needs, students strongly affirm the importance of comprehensive AI use guidelines. They believe that teachers should design assessments that discourage AI misuse and that universities should offer structured training on responsible AI use. These results indicate a demand for consistent institutional direction to ensure equity and integrity in AI adoption across courses and departments. And finally, the study explored how students humanize AI generated output. Students frequently verify sources suggested by AI and integrate personal or local examples into AI generated content. However, fewer students revise AI generated text to reflect their personal writing style. This suggests that while students engage in some personalization practices, deeper integration reflecting authorial identity and critical reflection remains limited and requires further instructional support. They try to personalize AI output but lacks advanced writing confidence and deeper integration skills. In summary, the findings portray students as ethically aware, cautious, and reflective users of AI. They value AI's role in supporting learning but remain conscious of the ethical risks associated with misuse. They express strong demand for institutional guidelines, structured training, and assessment designs that promote authentic learning for AI to be integrated responsibly into Philippine higher education. Universities must move beyond basic digital literacy toward comprehensive AI ethics education and human centered pedagogical frameworks. Students are ethically aware and cautiously optimistic, but responsible AI use requires institutional support. In conclusion, responsible AI use among students depends on three interconnected pillars: ethical literacy, institutional policy, and creative practice. Ethical literacy ensures that students understand the boundaries of authorship and originality. Institutional policy provides transparent guidelines that reduce ambiguity and inconsistency across programs. Creative practice equips students with the skills to adapt, critique, and humanize AI generated outputs. Together, these components will enable students to successfully navigate academic and professional environment increasingly shaped by intelligent technologies. Responsible AI use depends on ethical literacy, clear policy, and humanized AI practice. These are the recommendations on policy development. Universities should establish comprehensive AI guidelines that define acceptable academic applications, referencing norms, and data privacy measures. And educators need workshops on AI integrated assessment design, ensuring that learning tasks emphasize critical thinking and minimize opportunities for AI assisted dishonesty. AI literary integration, we have to embed AI ethics and human AI collaboration modules into general education and teacher training curricula, and conduct capacity building sessions on evaluating, citing, and personalizing AI outputs to strengthen authenticity and reflective writing. And future researchers should employ mixed or quantitative methods to explore students' motivations, ethical decision making, and longitudinal changes in AI literacy. Policies, conduct trainings, policies, faculty training, AI ethics integration, student workshop, and expand the research are needed. Thank you for your attention. I now welcome questions or insights regarding this study.
Hello.
Yes, ma'am.
Well, I think this study, like earlier, you had studied faculties, and now you have also taken perception of students.
Yes,
Great.
ma'am.
I have one question. Like, to what extent you have integrated AI in your institute?
It's still there's no policy yet, ma'am, but we see students use AI in their research, in their assignments, and the things that we let them do in the requirements. But
Okay, so do you do AI check as well?
yeah, we use instruments or the AI detecting tools.
Oh, your sample size is also good. The huge size you have taken. So that's all from my side.
Thank you, ma'am.
Thank you so much, ma'am. Thank you, ma'am, for presenting. Moving forward, I would like to request Ma'am Ananti Mulay to kindly present her paper titled Per Pixel Adversarial Perturbations for Proactive Deepfake Defense. Do we have you here with us, ma'am? Are any of the other teammates present? All right, since no one's responding, we will conclude the session here. Thank you so much, everyone, for your wonderful presentations.
Thank you,
I
ma'am.
sincerely, yes,
Thank you, ma'am.
thank you so much. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. And we, on behalf of the whole team, thank you for the support during this version of the conference. We'll be happy to have you in the next version in 2026 as well. All the presenters would be getting the digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of MCT4SD 2025. I also would like to thank our session chair, Dr. Hemlata Vivek Gaikwad, for chairing this session. Thank you so much, ma'am, for joining us. And here's a small token of appreciation from the team. And I just request you to share some words before we just conclude the session. Dr. Hemlata?
Hello.
Yes, ma'am.
Ma'am, it was great getting associated with you, and even I learned a lot from all the participants. I would like to thank participants. I could see a lot of different research which is being carried out globally. So it was a pleasure, and thank you, ma'am, for giving the opportunity.
Thank you so much, ma'am, for your valuable presence. And thank you to everyone else for joining. I now request everyone to switch on their cameras for a quick snapshot for the virtual conference before we end the session. Can everyone please turn on their cameras? All right. I'll be taking the snapshot. Is everyone ready? All right. 1, 2, 3. Thank you, everyone. Have a great day. And yes, thank you so much.